Okay, so we're working on this problem, number 6. We want to know what g of x is. Oh, is this recording? Whew. Yeah, it's working. So the main thing to note is that when you're setting this up, you put a single number up there, but when you have a quadratic factor in the denominator of one of these, I do bx plus c up there. So that's the way that's going to look. But then the rest of it is pretty much the same as what we did yesterday. So let's go ahead and actually do this. Multiply everything by the denominator, the common denominator. And so if you'll allow me, I'm just going to write it this way. 4x squared plus 7x plus 18 is the numerator on the left, which is the only thing that is left after you multiply by that common denominator. On the right, I end up with a times x squared plus 16 plus bx plus c times x plus 2. So it looks to me like it's going to be relatively easy to figure out what a is, because I can just stick x equals -2 into this thing. And what I get is 4 times 4 minus 14 plus 18 is equal to a times -2 quantity squared is 4, so that'll be 20 plus 0, because the -2 plus 2 is 0. So that's the easy part, hence maybe the question as to what do we do for b and c. Let me finish this, though, because I need this in order to get b and c. Let's see, 16 plus 18 is what, 34? And then minus 14 is 20, so 20 over 20. So a is 1. Well, that's convenient. So a is 1. Let me rewrite what I have here, but I'll put that 1 in there. Give me a sec. I'm lazy, so by rewriting, I mean I'm going to copy using the copy feature up here. Paste it in here. Give me a sec. I'll fix this. Rearrange. And then this thing goes away and becomes 1. There. So that's what we end up with at this stage. So we've got this. If you want, you can move this over to the left side. It's really unnecessary, though. But at this point, what are we going to do? Well, what we could do is notice that b is multiplied by x. So if I choose x to be equal to 0, then that's going to get rid of that. So sometimes you have to do a little bit more algebra than this, but this one is going to work out relatively easily because x equals 0 is going to give me this equation. 18 on the left side, 16 plus 2c on the right side. I know I just did that super quick, but just change all of the x's to zeros, and all that's left is the stuff that doesn't have x with it, c times 2 on the right. Look how convenient this is. That means that c equals 1. And now I can do another rewrite, or in my case, I'm just going to copy this. Give me a sec here. Copy and paste. And so for this final bit, what I'm going to need to do is I just need to pick a number. Any number will do. That will allow me to figure out what b should be. I could do this completely algebraically. Sorry, I got to change this c to 1. I could do this completely algebraically, actually expanding all of this, but that's a nightmare. It's terrible. That's the way I used to do all of these. And then somehow, I don't know how it took me until I was 50. Literally, I was 50 years old before I learned this shortcut method that doesn't involve a lot of algebra. But anyway, so I'm just thrilled with this. You could do the algebraic thing, but let's not. Just pick a number. If this works, it should be true for all values of x. And so let's pick a nice easy number like x equals 1 and shove that in here. There, does that work? That looks good. That can't be that hard. Now I can figure out what b is. So let's see, this is going to require just a little bit more work. I think on the left, if I move this 17 over, that'll become 1 plus 11 is 12. is equal to 3b plus 3. Sorry, plus 3. I said 3 and I wrote b. There. So after you deal with all the constants and multiply through by, and so then you get 3b equals 9, which means b equals 3. Nice. So there it is. So then that gives me my final answer for up here, whatever it is. Here, I'll type it in just to prove that I can do it. Um, so here we have f of x is just 1, if my memory serves me correct. Come on, where's that mouse? There it is. 1. And then g of x was 1 plus 3x, or 3x plus 1, I believe. Why is that x so big? That's better. Let me double check. Let me double check because I don't want to get this wrong. So I had up here bx plus c, and I found that my c was 1 and my b was 3. Yeah, sorry, I wrote it backwards. If it makes you feel better, I'll write it the right way. 3x plus 1. How about that? Let's see if, oh, it got it right. Yay. So yeah, the quadratics, they're a pain. You know, you have to use a linear term in the numerator. So at least we got one of them. Any others? So this wasn't terrible. I mean, it wasn't great, but it wasn't terrible. So I've got one, just one for your homework or your quiz here. Let's see how bad this is. I'm looking at it thinking, ooh, maybe this is worse than I thought it was. I think it's okay. Here it is up here on the screen, but I'll come around and give it to you. Oh, you can't see it. Here, I'll put it up on the screen. I'll give this to you, and then I'll even tell you the factors in case you're not sure how to factor that. I'll tell you the factors, and then hopefully you can go to it. We'll see how this works here. That's only two, I think. Here, I don't know how many that is. There's one back, you're going back there. There's not enough? Not enough. There's not enough here either. Let me do this. Now there's more than enough. So there's probably enough, I hope. Let's see if this is right. Okay, I'll come back. Anyone need one? All right, everyone's got one. Let me put the factors just in case you're not sure. I'm sure you can factor this, but this will speed us all along so that we're all in the same boat here. So this is going to equal something over x plus, oh, well, I guess I'm giving it away. Okay, I'll just write it. C over x plus 1, d over x minus 1. I should have just written the factors, but there it is. Since there's that quadratic x squared, you have to have an x and then an x squared. So there's four things you have to worry about. Let's see, are we still recording? We are recording. Excellent. Yeah. Which one? Oh, 2. Yeah, it should be 2. Sorry. What the heck? Wait, I only have 2 minutes left to be real. Just a sec. This is more important. Yeah, change it to 2 instead of 1. So there we go. Okay, we got it. We're good. We're good. Okay. It's only my family. They all think I don't know. My kids are all on Be Real, and so I'm just friends with them. Yeah, let me fix this this should be a 2. Sorry, I did it too quickly. You're right. You're right. Those are 2s. So let me fix it. I guess I need to fix a bunch of, just a minute. I already started doing my work, so let me move that down a little bit. Okay, I'll put it up on the screen here now. Hopefully this is correct. Sorry about that. There. Is that better? My bad. I don't know what I was thinking. I think I was just excited to be real. And then, there we go. Oh no, it didn't upload. Come on, after all that work. Come on. Upload failed. Click to try again. Oh no. Well, at least I can see my kids. They're doing great. They can't see me. How do we do that? Oh, try again. It's better. I tell you what, when you get done with this, you don't have to rewrite the whole thing. Just tell me what A, B, C, and D are, because it's not nice numbers that I'm getting, at least. Maybe you're getting, maybe I'm doing it wrong, but yeah, I think they're going to be ugly fractions. By the way, don't feel like you have to have it as a fraction. These could be decimals. That's fine. So if you want to type into the calculator, it's fine. Yeah, some of you are finishing up, and I just realized I don't have the heart to look at all of these fractions. Uh, so I'll give you another little bit, but then I'll just show you and you can check your own work. How about that way? Uh, yeah, I ended up collecting the quiz for Calc 1, and I looked at it. I gave it right back to them. I said, you fix this. Everyone had different answers. And I'm anticipating something similar possible here. We'll find out. All right, well, let me go ahead and show you what I have. Maybe you could just check your stuff. You might not have finished, but hopefully you got through most of it. So I know you can't see it because it's way at the bottom, but I guess there's all of my work. But well, let me just talk you through this. The first step is to clear out all these denominators by multiplying by that. And when you multiply both sides by this, you're left with 3x minus 1 here. And of course, each of these denominators are going to cancel in a different way. You're left with this stuff for this this stuff for this one, and so on. And then I just carefully chose values for x so that it would get rid of most of this stuff. So like x equals 0 gets rid of this, and that, and leaves the b. And hopefully I did the math right. So this is where, if you see a mistake, I'm happy to come clean and fix it. But when you let x equal 0, this is negative 4. And this is just negative 1, so b is 1/4. Then when you let x equals negative 2, I got negative 7 over here. X equals negative 2 makes this 0. This becomes 0, and that becomes 0, but this stays. So you have negative, let's see, negative 4 times 4 is negative 16, and negative 7. So I got that one right, I think. But once again, if I made an algebraic mistake, let me know. But it's all algebra at this point, so that's another reason why I'm like, let's just get it over with so we can move on to the actual calculus. The d, I chose to make x equals 2, because when x equals 2, these three become 0. That's the only one that sticks around. So when x equals 2, this is 2 plus 2 is 4, times 2 times 2, that's 16. And on the right, 2 times 3 minus 1, It's 5. I got that one right. So 5/16. The last one was a little tricky. What do you do for this a here? Just pick a number that isn't that hard to deal with, like 1. So when I picked 1, I got 3 times 1 minus 1, which is 2. Over here, let's see, this is 1, 3, oh, I messed up already. See, look at that. Good thing I talked through this. That should be -3, shouldn't it? Because 1, you could have chosen a different number, by the way. So there's nothing magical about the 1. I'm just picking something that'll work. So 1 times 3 times -1, which is -3. And then this will be b, that's 1/4, times 3 times -1. Seriously, I did this one wrong as well? 3 times -1. That should be a -3/4. Okay, so I'm totally wrong with this last one. So yeah, this is definitely wrong. And then c times 1 times -1. That'll be negative whatever this is. So that's correct. And then d times 1 times 3. So I should have 3 times this, which, okay, I got that right. Now let's see if I can clean up the rest of this mess. So that means that this is wrong. That means this is wrong. Hold on a minute. So I have -3 here. Let's see. So -7/16 plus 15/16 is 8/16, which is 1/2. 1/2 minus 3/4 is -1/4. -1/4 when you add it to both sides becomes +1/4. So +1/4 plus 2 is 9/4. And now I divide by -3 and I get -3/4. Okay, that's better. Okay, hopefully those are correct now. Whew. So much work to be done. And you're going to see why I split this into 3 parts, this unit or this section. And the reason is that that's only one of the 3 things that you have to do when you're doing calculus with this partial fractions thing. So what's the rest of it? Well, here's the rest of it. We're only going to do half of this today, though. So today, what we're going to be interested in is what the next step is. And the next step is what you would do if you were actually trying to do the antiderivative of that thing on the right or on the left. So if you did the antiderivative of the thing on the left, it's the same as the antiderivative of the thing on the right. So what I want to do today is I want to remind you of the basic integration rules that you already know. So I'm hoping that today won't be too painful. Tomorrow, though, is where we'll take the basic integration rules, we'll put it all together like this and do it all. That is, do the partial fractions, then do the basic integration rules. So bear with me, I've got 8 problems to work on, and they should be familiar. They should be things that you know, and so hopefully you recognize these and you can deal with them. So let's go ahead and take a look at this first one, the integral of 1 over x. Notice that the reason why I'm doing this is because if we were going to do integration by partial fractions, you're going to see this quite a bit. You're also going to see stuff like those. So that's the whole point of doing all of this. So let's deal with some of these that look a little bit more difficult, but I'll bet you'll remember. Jackson, do you remember the antiderivative of 1 over x? Very nice. That's the natural log of the absolute value of x plus c. We always remember to put that, or we always forget to put that absolute value in there, but it's important because the x here, if you don't put it in, would be restricted to just positive values of x. Very nice. Okay, the next one. Let's see how you do with this, Nolan. Do you know the antiderivative of 1 over x plus 1? It would be the same thing. Now, here's the thing. Back in the old days, when you were first learning about this, you probably had to do this. U is equal to x plus 1, du is equal to dx, which gives you this integral. sorry, I keep wanting to put x there, which will give you the natural log of the absolute value of u plus c, which becomes this. So just so you know, there is that going on in the background that Nolan was hesitant, and this is probably why you hesitated, is because you're like, wait a minute, this is supposed to be hard, but it isn't. You're right. It's just the natural log of the absolute value of x plus 1. You're good. All right, let's do the next one. I know everyone's excited now because you see the pattern, I hope. Drew, do you see the pattern? Do you know what the antiderivative is for this next one? All right, I got everything except for that first bit. I think I misheard you. You said 1 over 3. Is that what you said? Okay, yeah, 1 over 3. So this one, when things get tricky, even though I kind of scoffed at doing all of this stuff right here with the in red, it might be helpful to actually do that. So let me paste that in here and show you what it would look like if you did that here. So in this case, u wouldn't equal x plus 1. U is going to equal 3x minus 7. And that means that du is equal to 3 dx. So if you're not comfortable doing this one, number 3 in your head, please just, be humble about it and do it using so this ends up being 1/3. Do it using substitution. And the reason why that's 1/3 is because to make that substitution, I'm going to have to put a 3 in here. Let me actually do it. I'll put the 3 in there, but that 3 has to be balanced. So, so there's where that 1/3 came from, and then this becomes 1/3. But then we've got it. So we're good. We got this. We can do it. I know you're looking forward to look. There were 3 out of 8. I said I have 8 that I want to do. We're already 3/8 of the way there. Let's get halfway there. Ooh, where's my mug? Okay, let's see if you remember this one, Joshua. Do you remember this one? I've got a hint. It's not this mug. This one is my MVNU mug. But on my one mug, that's the students had inscribed it or laser. Well, I don't know what they did, but it's in my office. I should have brought it today. So familiar. It's my favorite derivative. Yeah, it's one that you should have memorized. But if you don't, it's okay because you're going to have it after today. I know that all of you have it, most of you. But let's see, Rachel. Do you know Rachel Junker? It is arctangent. Arctant. Now you're like, yeah, of course, right? Yeah, you knew it was one of those. You just didn't want to get it wrong. That's right. So this one you just have to have memorized. Arctan plus c. So there are two integrals that you have to have memorized for this section. Really, there's only these two. You have the arctangent of x, and you have the natural log of x. So you got those two, you're good. Well, except for the fact that, things like this show up. And I'll bet you can know you can guess what's going to happen next is we're going to mess around with this one to make it a little bit more complicated. Okay, so let's see if we can mess around. Oh, how about that? So remember, you're going to use the arctangent. So take a minute. This one is actually going to require a little bit more effort. Let me see, I'll move this one up a little bit. A little bit more effort than the others. You're actually going to have to do some work. With the others, you might have gotten away with not doing anything other than just writing it down. But this one, you actually have to write some stuff down, and I will do that too. But take a minute, see if you can figure out your first move. Oh, that's so fat. Why is it so fat? All right, let's give it a go here, see how we're doing. Eli, What do you think? What's the first thing that comes to mind as we're not even doing an antiderivative yet. We're just going to manipulate this a bit. So you have any ideas? Or did you actually just do the antiderivative? Like first thing that pops into your mind when you see this mathematical thing. So it's just blank. That's fine. It's just blank. Okay, sometimes that's the case. So this is a great example of my first class is getting so good at getting together and doing their homework as a group. So this is a great example of where like Eli could ask Luke or someone, oh yeah, Luke, yeah, let's just pretend that we're just working on this in the library. Luke, do you have any ideas? Because I don't know what to do. Use substitution, that's a great idea. So we would try use substitution and then you have a little problem, don't you? It doesn't perfectly work. So what goes on with the use substitution that's wrong?
It gets messed up as you go along.
Yeah. So the messed up part, let's just I'm not going to actually write, well, I'm going to do u substitution in a minute. But the thing that gets messed up is you say u is going to equal x squared plus 1, right? X squared plus 1 is u. Du is 2x dx. 2x dx. What is this doing here? That's the problem, isn't it? That 1. So the 1 is the problem. So we have to deal with the 1. So once again, this is just a simulation, pretending that we're in the library. These guys are working on this together. And so then we go to Connor, and like, Connor, do you have any idea? How can we get rid of the 1? Any ideas? Can we somehow get rid of the 1 before doing the substitution? And then suddenly you see your friend over across the way, and you're like, hey, Jackson, can you help us? Jackson, do you have any ideas on how to get rid of the 1?
If you split it into quantity 2x plus 1 times 1 over x squared plus 1.
Absolutely. That's what I'm going to do is I'm going to spread it, separate it. So I'll do exactly what Jackson said to do. Well, no, it's not that it's wrong. It's just a little bit more work than what I was thinking. I like it so far. Okay, you know what? That reminds me, we have the distributive law that we can do, can't we? Can we do the distributive law with this? Let's do it. So then you happen to text me and I'm like, just do the distributive law. And so then I do this. I've got 2x times this fraction plus 1 times that fraction. Okay, so it's a little bit more work than I was expecting, but it gets me to the same place. 2x over x squared plus 1 over x squared plus 1. Okay, so now you see it, and you'll be able to do this on your homework when you get to it. So does that make sense what we just did there? A lot of algebra. I would have actually, honestly, I would have preferred to leave out those 2 steps and just gone directly to here. But, sometimes it takes a circuitous route to get to the right answer, and that's fine. But any questions about any of this so far? So you believe all that? Okay, now I'm going to go back to Luke's original suggestion and say, you know what? Substitution makes a lot of sense when you're doing this integral right here. So I'm going to do substitution with that one. The other one, though, I'm not. So let me separate this into 2 separate integrals. And there's nothing wrong with that. X squared plus 1. And then this one over here. 1 over x squared plus 1. Hopefully you understand why I did that. But if not, it will become clear in a moment. So let's use Luke's suggestion of the u substitution. U is equal to x squared plus 1. Du is equal to 2x dx. That means this becomes the integral of 1 over u du. Hopefully that doesn't throw you too much. All I've done, I didn't bother rearranging this, but you have 2x dx there. That's 2x dx, which became the du down here. And then the rest of it is just 1 over u. Does that look all right? Okay. Now we can finish this up. We have 2 integrals to do, and who's going to do them? Ethan's going to do one of them. Ethan, which one do you want to do? The one over this one here, the red one, or the purple one? Red one, what do you got? That's right, one of our favorites, arctan of x. I'll just move that down there, plus the c at the end there. All right, let's deal with the 1 over u. We can do this. I'm sure you could, but you're not here. Madison can, though. Madison, what's the antiderivative of 1 over u? Very nice. So this is natural log of the absolute value of u, which becomes this thing right here, natural log of x squared plus 1. Boom. I'm sure that you can see how much joy we're going to have tomorrow when we actually combine this with partial fractions. This is just the warm-up. Okay, it's going to be okay. Let's try another one. Hopefully this one won't be too bad. Oof. Okay. All right. Before you get too discouraged, let me just say we're going to do almost exactly the same thing that you did with the previous problem. That is, separate this into two fractions. That'll be step 1. Go ahead and do that, and then pick one of the fractions to work on. One of them will be easy. The other one will be a little bit harder, but I think we're up to the task. We can do this. Ooh, I just remembered. We have an interlude here. I forgot. We'll do it. It's just sitting there waiting for us. You see what's coming. I know we whipped through those first 3 so quickly. Now we've ground to a screeching halt. But here, let me set this up for you again. We have the integral of 3x over 4x squared plus 9. And then the other integral is going to be the integral of negative 8 over 4x squared plus 9 dx. So I want to treat these separately because they're going to be, both of them are going to involve a substitution of some sort, but they're going to be different substitutions. So let's, to make it a little bit easier on ourselves, let's do this. And do that one first, and then after we do that, we'll deal with the other one. So let's just focus on that one. So let's go through and see if we can get the substitution. Luke, do you have a substitution you want to do for this? All right, 4x squared plus 9. Very nice. That would work. All right, Rachel P., what's the derivative of 4x squared plus 9? 8x. And then don't forget to tack on a dx because we're doing the derivative. So let's see. This thing, I'm going to have to rearrange this a bit. So give me a minute. I'm going to put a 3 here over 4x squared plus 9. All of that is going to just stay where it is. And then I'm going to multiply by 1 over 8 times 8x dx. So hopefully you see where everything ended up. I took the x that used to be up here and moved it over here. I stuck an 8 next to it, and I put a 1/8 there. So that's where everything ended up. When I get done substituting, this thing becomes the integral of 3/8 times 1 over u du. So you got the du here. Here's the u. So that hopefully doesn't cause too much grief. Something we're familiar with, right? We've done this sort of procedure before. It's not that big of a deal. It's not. So Mariah, what's the antiderivative of this thing? 3/8 natural log of that's so good. And then, of course, we want to resubstitute. Oh, let's go back to purple for the resubstituting. So that's 3/8 times the natural log of 4x squared plus 9 plus c. All right, looks good. That's only half the job, though. We have another half that we have to deal with, but it's okay if you find that you can separate your problem into two pieces. Just do one at a time, one and then the other piece. So it's totally okay to do it this way. And then let's go grab that other piece. Here's the other piece. In fact, I'm going to actually literally copy that piece there, copy it and paste it in down here. Paste, change the color. Oh, come on. Just a minute. Let's change to brown maybe. That looks good, doesn't it? Sort of. Okay, so just to keep it straight here, this one's a little bit harder, so let me work with you on this one. It looks like you're going to use some sort of arctangent. The problem is, where is the arctangent? That's the problem. And so the thing that I see that is the big issue is the 9. I'm not so concerned about the 4, but my arctangent, I know the derivative of arctangent is 1 over x squared plus 1, not 1 over x squared plus 9. So here's what I'm going to do to fix this situation, is I'm going to factor the 9 out, which feels weird, I know, but I think I've done this enough times that it shouldn't cause too much consternation. But notice that 9 times this is 4, and 9 times 1 is 9. So that's legal. It's just not something that your algebra teacher told you to do. You're used to doing the other way, right? Making things simpler. I just made things more complicated. But it's all legal algebra. Nothing fake here. So anyway, if you're okay with that, then you'll be okay with this. Negative, and I know this is the first time you've seen, maybe the first time you've seen something like this. So I'm going to pull the 8/9 way out, and then this becomes 2x over 3 squared plus 1. Okay, so this is also going to require me to use a substitution. The substitution is going to be for this stuff here. So why don't I just go ahead and do this so that you can see how to do this, deal with this sort of thing. Because this thing comes up when we're dealing with partial fractions. We'll see this sort of nastiness. So anyway, I've got u is equal to 2x over 3. du is equal to 2/3 dx. So I need to rearrange this just a little bit. So let me leave the 8/9 there. Let's leave the rest of this stuff where it is. So I'm going to multiply by 3/2 times 2/3. That way I'll get my 2/3 dx, and I'll be able to do the substitution at this point. So 8/9, I'm going to put that 3/2 out front. And then this will be 1 over u squared plus 1 times du. So this stuff became du. And then the 3/2 went out front with the 8/9, and I'll cancel that in just a minute. All right, now we all know this. I won't belabor this anymore. So this is arctan of u plus c, if you want to put the plus c in there. And then, of course, I need to do the resubstitution of this. So that equals negative 4/3 arctan of 2x over 3 plus c. So far, all right? I know, this is a lot to take in because it's something that you probably didn't explore fully back when you first learned about the antiderivatives of arctangent or the derivative of arctangent. Maybe not at all. Okay, so getting back to the final answer, let's see, my final answer I'll write up here is going to be, let's see, do it in some black maybe. So the final answer is going to be the sum of these things. We have 3/8 natural log of 4x squared plus 9 minus 4/3 times arctan of 2x over 3. And we only need a single c there. You don't need multiple c's. So So even though I have a C here and a C there, I just did that out of force of habit. But that's the final answer in all of its glory. Whew, it's rough. This is hard stuff. One more. I think we won't have time for the eighth one, but it'll be okay because the eighth one is just one. If we can deal with the next complication, I think that the last one isn't that big of a deal. So let's take a look at this number 7. I'm going to move it down a little bit to get it out of the way. After I do this, let me go back to 6. So was there anything else, anything about 6? I know other than the fact that it's really scary. Oh, yeah, Jackson.
Before you did the use substitution for the second half of it, yeah, how did you turn 4/9 x squared to 2x over 3 squared?
Okay, so I just used this rule from algebra that says that so I'll just deal with this one little piece here. That's 2 squared times x squared over 3 squared. So I recognized the 2 squared and the 3 squared. And then algebra says that when you have something like that, you can rewrite it like this. So those are just some rules of algebra. So I just recognized that 4 was 2 squared, 9 was 3 squared, and then I took all of that and rewrote it like that. So it's just an algebraic rewrite.
Would it have messed up the final answer if you had kept it as 4/9 x squared?
Yes, it would. Because then what are you going to do for your substitution? Like, because if you do u equals, you need something that you can, so now I actually have something that I can substitute for u. So yeah, I absolutely need that. Yeah, what do you think?
Are we ever going to run into problems where it's like 5 over 9 squared?
Maybe. I can't say for sure, but if you did, you could make, if it was 5/9 x squared, that's going to be the square root of 5 x over 3 quantity squared. So you could there's a way that you can deal with that. But yeah, I'm not on a test, but who knows what the homework's going to do to you? I don't know. I mean, hopefully not. I guess I'm choosing homework problems for you, so there you go. Okay, so this last one. This one, and the 8 was very similar to this. I just added one extra layer to it, but this will do. So when you see this, you might just be like, yeah, shut down. I can't do this because that doesn't factor. But what it does do is you could complete the square. And I know you probably remember the phrase completing the square. Yeah, here's the last one. It's the same idea. But you probably remember the phrase completing the square, and it may send, send you into some sort of a, I don't know, shock or whatever. But so let me just show you how this works, because here's how we're going to do this. X squared plus 2x plus, I'll put a blank there, and then I'll put the plus 2 here. Okay, so let me remind you about completing the square. Completing the square is a way of taking a quadratic and turning it into a perfect square. So x squared plus 2x, we just want to know what to put here to make that a perfect square. And the way you do this is you take this number, you divide that number by 2, and then you square that number. Square whatever you get, and you put it up there. So take whatever number is there, I have 2, divide by 2, I have 1, and then square it, and you put it there. That's what completing the square is. However, because I'm dealing with a mathematical object here and I don't want to change it, I have to follow the rules of algebra. And the rules of algebra say that if you add something, you better subtract it somewhere so that things balance. So I don't know if you remember actually doing this back in algebra class in 8th grade, because I'm sure it was 8th grade for most of you. But completing the square, you take that thing, divide it by 2, square it, that's what you're adding, and then don't forget to take away 1 from something. So if you're adding 1, you take away 1. Just to show you this one more time, if we were to do this one, you would have x squared plus 6x plus something, and then, plus 13. So there you take half of that, divide by 2 is 3, and then you square. 3 squared is 9, and that goes there, but then I have to subtract it off somewhere. Anyway, getting back to this, that's what I've got. Now what I've got is this, x plus 1. You'll end up with a perfect square, and the perfect square will always be x plus whatever number you got right there. So like down here, the perfect square that I get is going to be x plus 3 quantity squared. I'm hoping that this is just a jogging the memory thing where, oh yeah, we did that back, when I was a little kid. Okay, but anyway, there's what this ends up looking like. And now hopefully you can see that you can easily do a u substitution here. U is equal to x plus 1. Du is equal to dx. Look, do I have to actually write that down? I don't think so. U squared plus 1 du, which is going to be arctan, which if we put the x plus 1 back in, you end up with arctan of x plus 1. Wow. So this is going to be challenging, but once again, I am breaking this up into several chunks so that we can do this right. So before you go, I know that some of you are, have special friends, and tomorrow is Valentine's Day, and you might need a card for your special friend. So I have a series of cards that I gave to my wife over the various years. Some of you have seen this before in other classes, sorry. But so here's one of them. I'll show you where to find these if you need to download and edit them. So this sample of men asked to rate the amount of love they felt for their wives on a scale of 1 to 10. You can see this nice box and whisker plot here, and it turns out that I was an outlier. So isn't that nice? So I've got a bunch of these for you to choose from. There's a calculus one here where you have these limits, and then on the inside, it turns out even though each of our limits might be 0, and I applied the squeeze theorem to you and me, I find that the limit of our love is unbounded. Little double entendre there makes it more fun. My wife taught biology for a number of years, so I have this one. If you have a friend, a special friend, you know what I'm talking about here, who happens to be a biology major, you could say this. You and I go together like adenine and thymine. I know, isn't that cute? Okay, so just a couple others. We have this one. This is a little racy, so hold on to your hats here. We have this, which is a thing which helps people figure out what DNA is encoding. There are these various, normally it's a circle. I turned it into a heart. And then on the inside, I love the way you fold your proteins. I know that's a little bit racy. I've got my logo on the back. And then one more. If you have a friend who's not that special, I gave this to my colleagues a number of years ago on Valentine's Day. So it just has the Bible verse, see what great love the Father has lavished on us. And then you need more evidence that God loves us. He also gave us mathematics. Happy Valentine's Day. This is all available along with a bunch more of these in my Valentine's folder on your Moodle site. So if you go to Moodle, you will find this stuff. So feel free to download, edit, and so it should be right on tomorrow's. If I can get this to pull up here. Yeah, Valentine's, there it is. So if you click that, you get that, and you can download and edit if you need to. So you're welcome, by the way. If you forgot, now you know, and you can enjoy tomorrow a little bit more. All right, we'll see you tomorrow. If you want to stick around, I'm going to stop the recording. I think so. I should probably check my schedule before saying that for sure. Give me a sec here. Wait, why is it?